Hello, this video is on translations and reflections. First we're going to start with translations, and we know that translations move points horizontally and vertically. So, to represent those, we're actually going to call them H and K. So H is going to stand for horizontal, and K is going to stand for vertical. Now, when you think about a coordinate grid, which looks like this, we have an x-axis and a y-axis. So, our x one is our horizontal one, a little h for horizontal, and our y-axis goes up and down, that's our vertical one. So, whenever we're talking about translations, our x always goes horizontal, left and right, and our y always goes up and down. So let's just pretend we have the point xy. Technically, every point is the point xy. You always have an x coordinate and a y coordinate. So whatever number x is and whatever number y is. Now, we will know its translation by h and k. So x is always going to be changed by h, whatever h is, and then y is always going to be changed by whatever k is. So if we move up 2, x is going to be plus 2, whatever it was. And if we go right 4, y is going to be 4 more than it was. Now, something to keep in mind. Anytime you go up or right, you are using addition. However, anytime you go down or left, we're going to subtract. Which makes sense. When you think about it on a coordinate grid, all our numbers that are right and up are positive numbers, which represent addition, and all the numbers to the left and down are negative numbers, which would be subtraction. So that's how you keep it straight. So if we're going to actually look at one, I've given us this triangle and went ahead and labeled the points. Now let's just say I want to translate this triangle down 4. Normally we would just count each point down 4. So down 1, 2, 3, 4. There's this new point. Down 1, 2, 3, 4. And down 1, 2, 3, 4. So here's my new triangle in orange. Now let's look at these points. This point here, 1, 2, 3, 4, 5, 6, 7. This point up here, 1, 2, 3, 4, 5, 6. Sorry, it's getting a little bit. 6, 3. And this point down here, 1, 2, 3, 4. Here's our new points. Now let's look at what happened. All my x's were 6, 7, 4. My x's are still 6, 7, and 4. My x's didn't change. My x's didn't change because I moved down. X goes left and right. I didn't go left or right. I went down. So only my y's changed. And they changed by 4. 7 minus 4 is 3. 3 minus 4 is negative 1. 2 minus 4 is negative 2. So I used those points to move. Now, let's just say it said translate down 4 and we'll say right 6. Okay, so we've already done our down 4. Now we need to go to the right 6. So I can count each point over 6. Start with this one. 1, 2, 3, 4, 5, 6. This one. 1, 2, 3, 4, 5, 6. And then this one. 1, 2, 3, 4, 5, 6. There's my new triangle. Now the points here are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, down 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, down 1. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, up 3. Now, let's look at these points compared to my original ones in blue. So let's ignore the orange for a moment and just look at my blue points. If I went down 4 and right 6, that means my y is going to be minus 4, and then my x is going to be plus 6. So let's look. 6 plus 6 gives me 12. 7 minus 4 gives me 3. There's that point. This one. 7, excuse me, 7 plus 6 gives me 13. 3 minus 4 gives me negative 1. There's that point. And the last one here, 4 plus 6 gives me 10. And then 2 minus 4 gives me negative 2. So even if I do two different translations, go down and right or up and left or any combination, I can still use the same rules. But anytime I go up and down, it's going to change my y value. Anytime I go right and left, it's going to change my x. Next we have reflections. So, given this original trapezoid, and it says to reflect over the y-axis. So my y-axis here, one going up and down, my vertical one. If I want to reflect over my y-axis, now remember a reflection is just a mirror image. It means you flip it. So the distance you are from the axis, it needs to be the same distance on the other side. Here I'm 1 away, so on this side I need to be 1 away. On this side I'm 8 away, so 1, 2, 4, 5, 6, 7, 8. I'm 3 away, and I'm 6 away. Here's my new trapezoid. Now we can do this without graphing it at all, just from looking at our points. So let's look at our new points. I now have 1, 5. I have 8, 5. 6, 2. And 3, 2. Now, what happened between my red points and my purple points? If you notice, the sign for my x changed. Here, all of my x's were negative. Now, all of my x's are positive. My y's didn't change at all. So, we can say the rule for reflecting over the y-axis so anytime I reflect over the y, my x's change. So let's say I start with the point xy. My new point is going to be the opposite of whatever x was. So in this case, negative xy. We did that. Now, this time what if I reflect over the x-axis? So let's just look at our red one here. Ignore the purple. If I want to reflect over the x-axis, that's the horizontal one. Same thing, I have to be the same distance. So here I'm 2 away from the line, I need to be 2 away from the line. Same with this one. Here I'm 5 away from the line. And here I'm 5 away from the line. So here's my new trapezoid. Now if I look at these points, I have negative 3, negative 2, negative 6, negative 2, negative 8, negative 5, and negative 1, negative 5. What do you notice between the red trapezoid and the green trapezoid? What happened to the points? If you look, all of my x's stayed the exact same, but my y's turned negative this time. So we could say that when we flip over the x-axis, if I start with the point xy, this time my y's are going to change sign. Now what happens when I go diagonally? For instance, reflecting over y equals x. I want to reflect over y equals x, flipping over this line. So the way this one works is actually the x and the y change places. So I look at this, I'm at what? 8. I'm currently at 6, 4. If they change places, I'll be at 4, 6. Here, I'm at 4, 1. When they change places, I'll be at 1, 4. And this one, I'm at 9, 3. When they change places, I'll be at 3, 9. So if you look, my triangle has now reflected over the line y equals x. Notice all the points are still the same distance. It's just a mirror reflection. Now what about the other way? What if I reflect over the line y equals negative x? When this happens, not only do they change places, they also change signs. So what I mean by that is I have the point negative 5, 9. If they change places, that makes 9 negative 5, but I also need them to change signs. So that means I need negative 9, positive 5. So if I go negative 9, positive 5, that new point is here. Negative 2, 11 would become negative 11, positive 2. And then negative 4, 14 would become negative 14, positive 4. And there's my new triangle. Perfect reflection over the line y equals negative x. So to get my new rules down, anytime I reflect over y equals x, my x and y, my original coordinate, they simply change places. So now I'm going to have y and then x. And then when they flip over y equals negative x, my original point of xy becomes, they're switched, and they're the opposite sign. So I would have negative y, negative x. So we know how to graph these by counting points. Now we can also do it just from looking at our signs here. So if you're given simply the signs, you don't need graph paper to graph it and then to count all the points. You can simply just use the rule. And this is how you do translations and reflections.